All right, so what school are you guys from?
East Grand Rapids Middle School.
East Grand Rapids Middle School. Okay. And what are your names?
Terry.
Tim.
Anna.
Okay.
That's Emma.
And what is the name of your team, or do you have a team name?
Pioneer Robotics.
Why Pioneer?
The Pioneer satellite, and also our high school mascot is the Pioneers. And so we tried to change it to be more technology related and STEM related. So we're doing the Pioneer satellites, which is a satellite mission that NASA did back in the day.
And we are actually hoping to get the school's mascot changed to the Pioneer satellite because we love
This,
it.
it's
What
on our
is your
shirt.
current mascot?
It's a Pioneer guy.
It's not
No, it's spelled
really
for.
that accurate.
Not the
No, it's
team
spelled for.
mascot is not. The team mascot is the satellite.
Okay.
Yeah.
So the school mascot is a Pioneer of
Yeah.
some sort.
Yeah.
Okay. When did you start actually building your robot over here?
Well, we started prototyping 2 months ago when the competition first came out, and we started actually assembling it. I'd say 1.5 months ago. We started with the drivetrain and stuff.
Like the middle of September?
Yeah, about the middle of September.
So when does the problem come out that you know what you need to build?
That was at the beginning of September,
Like
late
the
August.
7th, I think.
We
September
had-
7th at the
We had
FGC.
the
There's a whole.
We knew that we were gonna do this grabber.
He's asking about when when the game was.
Oh,
Well, yeah, I was particularly interested in like how much of this was built before then.
Oh,
None of it.
None of it. No.
None of it? I mean,
No.
like nothing from last year?
No.
No.
Yeah, we have a robot from last year, and then we were there on the release day at an event at Grand Valley University, and we watched the video, and then we started brainstorming right away.
Okay.
Yeah.
So, and how did you build this? Is it just like screws and bolts, or what did you have to do to build it?
It's various different parts. It consists of Tetrix, Rev. Yeah, there's tons of different parts. 3D printed stuff.
Super Droid robotic stuff.
Red.
Yeah.
Oh, Tornado. Pretty sure we have one
Yeah.
Tornado.
So we use a variety of different parts, and we try to combine them together best
Some
we
are
can.
modified, like some we cut.
Yep, to fit our needs the best we can. Yeah. So we use whatever parts would suit us best.
Do you have like cost limit when you're building?
well,
It's
he's
based
the
on-
finance
Oh,
guy.
I-
He raised the money.
Our cost limit for the robot this year was, I'm pretty sure, around $3,000.
Yep. That sounds right.
Or 3,000, and then
Is that what part of the rules, or is that just based on what you had for
no,
cash on hand?
that's just it's kind of I set the limit normally. I like to set a limit so we don't go crazy, and then we don't like I guess spend too little to the point where like our robot isn't proceeding to how we want it to form.
We do
And then I also
30
set like how much like
Yeah.
money we income.
We do reuse a lot of our parts from previous years from
Yeah.
really old robots. We'll take those robots apart from like 2 years ago, and we'll use parts on our new robot for that.
Oh, okay. But
like-
for some reason, you're preserving last year's robot?
We like to preserve last year's robot for outreach. That way, this year's robot doesn't get damaged or anything while we go to outreach events. But we can still show what first is and what robots we build and stuff like
The
that.
amount we spend always fluctuates. Like it always goes. Like last year was a little less. This year was a little more.
Okay, so some of these parts are reused from much older robots. then.
Yeah.
Some of them are, but we made sure they're all in good condition too to
Yeah.
be working and stuff like that. So the parts that you see reused are stuff like rev bars and Tetrix stuff. We don't use any. We don't.
Two screws.
We use more new electronics. We don't use like past year's
servos,
electronics.
motors,
Yeah.
transmission hubs.
Yeah.
But yeah.
It looks like you have a lot of the robots seem to have a phone on them. What's the purpose of the phone?
Yeah. The phone. Does Theo wanna tell us about the phone? Yeah.
Yeah, so the phone has
Do you have a phone in yours?
here. Yeah,
Oh,
we-
it goes there.
Yeah.
It goes there. Yeah.
And well, we load the code on it and compile it, and it's connected to the driver-controlled phone, where the driver-controlled phone has the inputs of the controller, and I think it's the robot-controlled phone. It also has what all the motors are, because in the code we define these motors, but then we map them on the FTC app.
Cool. What other questions do we have there? What was different about this year's competition from last year's competition?
The height.
The height was a huge difference for us. Our past robots have always been maxing out the height limit pretty much on the sizing cube. So this year was really an opportunity for us to try to decrease that height a lot.
Our drivetrain is also
Fit under the bridge.
different. We've never used
Mechanism wheels, yeah.
What kind of wheels are they?
They're Mecca wheels, so they can go sideways. So the robot can go sideways without turning.
Cool.
This year we have to be really exact when we place the box.
Okay. So last year the rule didn't require you to be exact with the block placement?
Yeah, because when we would put silver into the slot last year, you could put it. It was
It was
about
such
that.
a big slot.
Yeah, it was about
it was
that
a
long,
bigger
a bigger slot. This year, since you have to line
And if you want to
the
stack it,
yeah, you have to line the sky stones up pretty well, but we can stack an average of I'd say 4 to 5 blocks, 4 blocks.
our maximum is 6.
well, that's pretty hard to do in an actual
Yeah.
competition.
But yeah, we haven't done a competition yet, 6, but we have an average of 4 blocks stacked.
Cool.
You can see it on the poster.
Does everyone do the construction and the program, or are there other roles on the team?
There's lots of
So we run our team like an engineering company would, because we work in an actual engineering company called Array of Engineers. So everybody fills out a form at the beginning of the year, saying their interests and their dislikes, and then our mentors and coaches will take it from there, and they'll figure out what's best to place everybody, and then everybody gets the opportunity to try out different jobs on the team, and then once we figure that all out, then everybody kind of goes and helps with their own jobs. So Johnny, for example, does business and finance. Theo was a prototyper, a builder, and a coder. Gray was a big prototyper and builder. I did a lot of outreach and building, and various. Yeah,
Carrie
we all.
did
I was a prototyper.
Innovation Notebook.
So yeah, we all have various different tasks, but we all took some part in one way or another to get this robot built.
Did we have any other questions on the list?
I was just wondering, how many motors did you have on this thing?
We have 6 motors.
4 for the drivetrain, 1 for this arm to extend, and 1 for it to go up.
How many servos do you have?
We also have 4 servos, 2 in the front to move the foundation, 1 to move the grabber up and down, and 1 to open and close the grabber.
So what's the difference between a servo and a motor?
So motors, these are DC motors, and they spin continuously.
They have a little more torque.
They have more torque and they're more powerful. And servos are more meant for like fine movement, up and down, and they're much lighter and smaller.
And servos can stay in place when the robot's turned off. They won't fall down. Whereas like a motor, for example, it would fall. It would just let loose and fall down.
We also have a worm gear. Can you mention worm gear?
Yeah, so one of the things on the robot this year is called a worm gear. And if you come back here, what a worm gear does is we have a motor all the way at the bottom of the robot that turns, and it turns another gear, which then turns this gear, which then makes the arm go up. But the benefits to a worm gear is it's a really strong gear, and it also it stays in place after you turn off the robot.
Worm gears can only rotate in the one direction, so you can't move the arm down. Worm gear, you can't spin it that way.
You can't spin it down, but the arm still goes down. Yeah.
Can we talk about odometer wheels?
Yeah. Another unique feature is the
So on the bottom we have these wheels that measure how far we go, and because these wheels, they're prone to slipping, so these wheels are always staying on the ground, and they just measure what we have using these encoders right here.
And they're omni wheels, so we can go side to side. With
Yeah, so
our
these wheels can
metronome
spin
wheels.
both ways due to these. So
And they have rubber bands. so
they have
up or
rubber
down.
bands to keep them on the ground.
That's one of the big things that I think sets our robot apart from others.
Yeah.
And we got the lights for our webcam that we use when it's darker.
No, they don't work that well.
No, we do. They work when it's dark.
No, we have.
Yeah, they do.
yeah,
We
they
didn't.
Yeah, they work
I don't
when
think
it's
they were
dark.
working last year.
No, they work when it's dark.
I was doing.
They do light up a dark area.
Yeah.
Oh, does it look like the sky stone and stuff?
No, it helps when it's dark.
Yeah, it does. We have a web camera right here.
Yeah.
So that's what will register the Sky Stone for autonomous.
Oh, and we
and
talk
that's
about
how our
sensors?
robot knows where the Sky Stone is and what to grab.
The Sky Stone, that's the large,
That's
kind of rectangular.
Yep, with the picture on the front of it.
Oh, the one that has the picture
Yeah.
on it.
those
Okay.
are worth more.
Our robot also has 11 sensors. 2 time of flight. Do you know the others?
Yes, we have
Oh,
one
great.
potentiometer right here,
What does that do?
This can read the angle of this arm as a voltage. We can
Okay.
convert that to an angle. And then on the bottom, we have the odometer wheels, which all have encoders on them.
Right.
And then we also have the webcam, another encoder on this wheel, and one more on down here.
And then 2 time of flights.
What are? Did you say time of flight?
Time of flight laser sensors.
So basically what they do is they send out a beam of light, it bounces back, and it sees how long it takes to come back, and it calculates that using the speed of light to a distance.
So it's kind of like an ultrasonic sensor except with light.
Light instead of sound.
That's very cool. What was? How did competition go for you guys today?
Well, half decent.
We our drivers I think performed the best at their peak level. We had at one point we had one of our motors break, so that was a big fix we had to do. We had to replace a motor.
We had
But-
to grab an adapter.
Yeah,
Oh,
after
yeah.
that dilemma though, our robot's been performing great,
Yeah.
and our drivers I think are doing the best that they can.
And now we're in 7th.
And it's a really fun way
Wait,
to.
we're in 7th now?
Last time I checked.
So yeah, we're pretty competitive.
It's
Okay.
a really fun way to learn.
We like
about
to have
STEM.
fun as a team though.
So for when is the next competition that you guys go to then?
Paloma, which is December 9th.
Yeah.
Early December.
Is that another qualifier or is that like
Yeah,
state?
Another qualifier.
it's another qualifier. So if we win here or win any awards here,
Then we'll be going to Battle Creek.
then we'll be going to Battle Creek automatically. Well, certain
Inspire.
awards.
We do ball.
But if we don't win here, we also have Coloma as another shot to win.
And by Coloma, we'll be more ready. Like,
Okay.
we'll-
So is this your first competition of the season then?
This is
Yeah.
our first season. Yep.
So you're doing 2 competitions and hopefully then you go to
Yeah.
Hopefully.
states.
Yep. Past last year. Last year we went to states as well. So
Yeah.
yeah.
Very cool.
We're as competitive as we want to be this year as we were last year at states. I think we're gonna do a little better this year if we make it to states.
All right. Any other questions?
Awesome. Yeah. I hope you guys start a first team then. It's
Yeah.
really fun. It's a good way to learn about STEM and to meet other people in your community and to learn how to lead. And it's a great way to make
Also,
friends.
I would
too.
highly recommend getting sponsors. They really help financially. They donate money, you put their name somewhere. It's a win-win for both people. It's really helpful. Get sponsors. Get good sponsors that will help.
We are about to form a team if possible this year. Thornapple Kellogg. That's
Mainly we're looking for next season because if you guys, it sounds like you guys have to be really ready at the start of September
Oh,
with
yeah.
all your orders. You have to have all your parts and everything and your team formed and
Yeah, and I suggest like it. I guess it doesn't really matter how many people you have, but have people working groups, like small groups, because it's not good if you just tell everyone.
Yeah,
to
you
do
want
the same
everybody.
thing.
You want everybody to be working on a certain task. You don't want like everybody just working on building. Like I was spending. I like building. Don't get me wrong, but I knew what was best for the team, and I knew somebody had to type up the financials, so I went ahead and did that. So you gotta be a team player. You can't just look out for yourself.
okay, very cool. Thank you very much for the interview. Good luck.